Hey guys, how's it going? This is Carl, and this is week 11, problem number 1. And we'll just go ahead and get started. A market analyst wants to know whether a website he developed, or she, is showing an increased page view per visit. A customer is randomly selected and sent to one of the two different websites offering the same products but different designs. This table right here shows the data of 5 randomly chosen customers from each website. So we need to test the null hypothesis that the mean number of page visits is the same for the two websites, and assume that the data from the population is normally distributed, and assume that the new website is website 1, this one right here, and the old website is website 2. So kind of getting started, just want to give you a sense of kind of the variables and the formulas that we'll need to kind of help this flesh this out, whether or not we want to test if there is a measurable difference or an observed difference between the two websites based on these randomly chosen consumers, or customers rather. So first thing we'll know is the mean. The mean in statistics, y bar. So, and I'll just spell it out. So there's kind of a bar, you've seen it before. So in calculating it for this group, it's simply the average in Excel, as you can see right here. And the average in Excel. So 8.6 for website 1, 8.2 for website 2. The standard deviation, same thing. We'll use the formula stdev. And same thing here. So 3.6, 3.11. Keeping these two columns together, these represent website 1 and website 2. The variance. Now there's two things you can do for the variance, but I just chose the simpler way. If you remember, the standard deviation is the square root of the variance. So flip it around, and it's just the standard deviation squared. If you did variance, it'd be the same way, and actually you would get the same value if you do it right here. You can tell variance right here. We'll do the traditional Excel value right here. So, for example, the variance of this website 2 values right here will get you the same. So just FYI. So you can see it's the same value itself. Y bar minus Y bar 2, essentially, you're taking those two means, subtracting. And then the standard error of Y bar minus Y bar 1. Now this is a little complicated. So basically, it's the square root of this 9.7 divided by n. So S, the variance, S squared divided by n. So what is n? Well, n is 5. Where did I get 5 from? Well, n is the population, and this is it. 1, 2, 3, 4, 5. And you notice the populations are exactly the same. So it's you're comparing both groups, and that's what we're doing here. So A19 is your variance, 9.7 divided by 5, and then you're comparing it with this variable. So, and that gets you 2.114. So one of our first things that we'll need to do is calculate the t-statistic. And so how do we calculate the t-statistic? How do we get this value? Well, it's B21, which in observation is y bar 1 minus y bar 2 divided by your SE, y bar 1 minus y bar 2. But you'll notice the 0. So what is the 0? That's the hypothesized difference. So actually, your formula for calculating the t-statistic, is y bar 1 minus y bar 2 in parentheses minus the hypothesized difference divided by the standard error of y bar 1 minus y bar 2. So what is the hypothesized difference? That there is no difference. So that's why that 0 value, that's where that comes from in this case. And so continuing on, calculating the degrees of freedom. So there's two ways we calculate the degrees of freedom, and we're actually going to walk through it. The first way is talking about the formulaic way of doing it, and that looks cumbersome over here. Up top, 13.3 divided by 5, 9.7 divided by 5, those two squared, then divided by 1 divided by 5 minus 1 times 13.3. So what are we actually doing? What does this actually mean? This actually means that we're using our variances divided by n. So this is s squared 1 divided by n1, s squared 2 divided by n2, and this whole product is, this whole addition is squared, and then divided by, so this is your numerator, this part is your numerator, this part right here is your denominator. 1 divided by 5 minus 1. Where's the 5 again? Remember, the 5 is your n. So 1 divided by n minus 1 times, here it is again, your variance, s squared 1 divided by n 1 squared plus 1 minus 5 minus 1, because remember they don't change because they're the same size, s2 divided by n2 and then squared. So that gets you the degrees of freedom in this aspect. Now calculate the degrees of freedom using the rule that the minimum n1 minus 1, n2 minus 1. And using that rule, as you can see, it's 4. And it's simply the total that we have, 5 minus 1. So it's pretty cut and dry, and it's probably the traditional sense of what you're familiar with degrees of freedom. So using the p-value, we'll just scroll down a little bit. Find the p-value using the degrees of freedom from part B, our calculated degrees of freedom. So you'll see, how do we do that? T-distribution. So what did we do in our t-distribution function? First, we're using what's our value for x in this case? Well, now, when I say x, I meant that the way it's from, right here. What's our value what's our t value? That's what that really insinuates. So that is, of course, our t statistic, which is that. And then what else we need is our degrees of freedom, which is this value right here. And then, lastly, if you'll notice at this top, the tails. Remember in the question, it's a one-tailed exercise. So 0.4286. And what happens, and we'll get to this a little bit later. And then second, find the value using the degrees of freedom from part C, or the minimum rule, n minus 1, n1 minus 1, n2 minus 1. So you'll notice that these are almost essentially the same. The only thing that's different is our degrees of freedom is 7.8 in this case, and then 4 in this case. And you'll see how just close they are. Rounding to the nearest 100th place, they're basically the same value. Although this one is a little more smaller. So what do you conclude at alpha equals 0.05, that the null hypothesis that the mean number of page views is the same for the websites, and the alternative hypothesis is the mean number of pages greater than for 1 than for 2, 2 being the old, 1 being the new. And remember, the p-value is less than or equal to alpha, we can conclude that there is sufficient evidence to reject the null. If p-value is greater than alpha, then we fail to reject the null. And as you can see here, I've just kind of set up, if you remember back, the if statement, it's a really good way to test p-values, and really fast way, and actually kind of an accurate way if you're kind of doing multiple hypothesis tests. F22, what's F22 over here in this case? It is our p-value using this degrees of freedom. See? And so, fail to reject the null. It is greater than or equal than 0.05. So you can see how it works. So as we say in our statements, you can see right here, 0.05. If it's less than or equal to. So because that value is obviously greater, then we have to fail to reject the null. And we hope this helps, and just let us know if you have any other questions. Thanks so much.